have a look at these three rivers and start to think, how are they different? And also, why are they different? So how are they different? Well, you can see the rivers, they're different shapes, different sizes. But what is significant is about the drainage basin, so the surrounding area, the valley that it falls into, they're all very different. You've got what looks like an urbanised area here. It's also very flat. This one, mostly agricultural land, some gentle slopes. This one, incredibly rocky, looks like a more resistant rock, so a different type of geology. Also, it's in a mountainous area. So how are they different? Different shapes, different sizes. And why are they different? Well, ultimately, it comes down to things like the geology, the climate, and we'll go through all of those things over the next couple of lessons. So we'll look at drainage basins today, and you just had a go interpreting some images, which we'll come back to later. So we are here, still within the processes that are operating within the hydrological cycle. And we're looking at the fact that it's a system of linked processes. So look at the inputs, things like precipitation and different types, flows, and then outputs. We're not going to get into the kind of science behind that today. We're just going to introduce these drainage basins, and we'll start thinking about this in more detail after the holidays. So a drainage basin then. Draw yourself this simple diagram, and I want you to add some labels to it. So this is linking quite strongly back to GCSE. So what's the watershed? What's the confluence? What's the tributary? What's the source? What's the mouth? What actually is the drainage basin? Where are the headwaters? And where's the floodplain? And finally, where's the stream channel? So let's draw that in pencil, get those labels added on. Here you go. So this is just a different type of diagram, I suppose. Your watershed is on here, it's the red line all the way around the outside. You can see it's the highlands surrounding your drainage basin. Any rain, precipitation that falls within that watershed will end up at some point in that river channel. Your confluence is where two rivers join. So this would be a confluence, this would be a confluence, this would be a confluence. A tributary, that's a smaller stream that joins the main channel. Source, well, that's where your river starts. So probably the source on this one's probably up here somewhere. The mouth, that's where it ends, so where it flows into a river, into a lake or the sea. The drainage basin, well, that's the whole thing. Headwaters, your headwaters are up near the source, so it's up in the mountainous, hilly sections where these little streams start up in the upper course. The floodplain, that would be here, surrounding that main channel, down towards its mouth and its lower course. And then the floodplain, we've done that, stream channel, that's obviously the bit that the water flows in. So you'll have your simplified diagram that just shows you what it actually looks like, bringing in things like the groundwater, the water table. So it's the groundwater, remember, that maintains the amount of water in that river. That's the base flow of it. So your drainage basin, it's an open system because it's a part of your global hydrological cycle. We know the global system is closed because you never add anything, you never take anything away. But because a drainage basin is only within this watershed, that's open because precipitation can come in, and as the water flows, it leaves. If water evaporates, it leaves. So this is an open system with inputs and outputs. So this is a systems diagram here, which just shows you your inputs, firstly in blue with your precipitation, your stores in green, your flows in yellow, and your outputs in your lighter blue. So I want you to draw yourself a simplified version of that. And then I want you to add any labels to explain any of the key terms that perhaps you don't know. So if you don't know what things like through flow are, groundwater storage, I know we did these, last lesson, last week, but you need to be clear and certain on what these words actually mean. I then want you to answer, well, why is the drainage basin an open system? What makes it an open system? And you've got all of your key terms here. in case you need them. Make sure you colour code them so you know which ones are the inputs, which ones are the outputs. You might want to explain why it's an input, the fact that it's coming into the system, output, that it's leaving the system. And then this diagram here, this just shows you where it actually fits within different parts of your drainage basin. So this is a systems diagram. This is a diagram. So now that we've learned that, I want you to apply it to the images that we looked at the start. So how are these rivers different? Why are these rivers different? So for example, how might the inputs be different, the precipitation, different areas? You might have to make an assumption. How might things like interception be different? How might through flow be different, surface runoff? You're not going to know for definite, so you've just got to apply what you know and think, oh, we've got some slopes, therefore infiltration might not be as high. This one's got, it's quite rocky, therefore infiltration might not be as high, so you might have more runoff, which means you have a lower store of soil moisture. This one's quite flat, but it looks quite dry. So just apply what you know, try and make some assumptions from it. Right, so this is all these key terms. I want you to pick 5 of them, well, at least 5 of them, pick more if you like, and I want you to have a go at explaining how they are connected. So basically put them into a paragraph. For example, I might say, the drainage basin has one input, and that is precipitation. This can fall from the sky as rainfall. If it lands on vegetation, it can be intercepted and temporarily stored by those trees, or it can land on the ground and it can infiltrate into the soil, adding to the soil moisture. Eventually, it can percolate down into groundwater, where it's held within those permeable rocks. Over time, that can slowly move as groundwater flow. Here we go, yeah, it's there. Into your river, where it increases river discharge and it leaves the system as an output. So all I've done is I've just explained movement of water by using a range of those key terms, and I'd like you to do the same. So I think I've asked you to write that as a comment on showing my homework. And then final thing, spelling test. So I've just put some key terms that we've gone through today. I want you to have a go at spelling them for me, please. And that is it for today. After half term, we'll go through in more detail, look at those physical factors that influence your drainage basin. All right, take care. Bye-bye.